welcome to Helm of Science. The festive season have already started, so there is a little pressure on everyone's head about the studies. And today we are going to learn about an very interesting concept on physics, which is nothing but Newton's laws of motion. You all know that there is total 3 laws of motion, and which are the fundamental laws in the classical mechanics or in the physics, study of physics. So today the most important part of this video will going to be the experimental analysis of these 3 important laws, not only the mathematical or the theoretical analysis. So let's get started. So the first law is every body will state or remain in that state or in a motion, in a state of rest or in a motion, unless acted upon by an external force. So this is generally known as the law of inertia. Though this law was first discovered by Galileo, but later this law was experimentally done and verified by Newton. So this was our first law, and our second law is the law of force, generally known as the law of force, and which states that the amount of acceleration of a body will depend on 2 things. Acceleration, you know, that is the rate of change of the velocity. This will depend on 2 things. First, it will linearly proportional to the force acting on that body, and it is inversely proportional to the mass of the body. So acceleration is linearly proportional to the force acting on the body and the mass of the body. So taking account in these 2, A is F by m. A is proportional to F by m. Generally it is written as A is equal to F by m, or in a simpler term, F is equal to m dot A. You can also say that the force on a body will be equal to the product of mass and the acceleration of the body. So this defines the force, that is, what force are you acting on a body, or what the acceleration it is getting for a fixed constant body. That will be the the mass. If the mass is constant, if the force is higher, the acceleration will be higher, and if the force is lower, the acceleration will be equally lower. And this if the acceleration is lower, the velocity of the body will be lower, and the vice versa. So what we can conclude from this, if we apply greater force, we will achieve higher velocity, isn't it? If we apply more power to our cycle pedal, the cycle will run faster. So this is very simple. And the third equation or third law is the most famous law we use in daily life as a joke or everything, but the law is most important and efficient law. If this law was not present, there will be a lot of difficulties we could face in our real life. The law states that every action has an equal but opposite reaction. This is the action reaction law. So when you are acting a force or doing an action to another body, the body will also do the same action but towards you. That is called the reaction. Suppose we are pushing a block right there, so the block will also apply a equal force on us. So now we will experimentally verify these three equation or the laws of motion. The experiments will be homemade experiments, so there is no such big machines. You can also try this experiment and make physics learning a fun. This is not a boring subject, and you can get interest from everyday life using physics. So let's get started. So before starting the experiment, I will introduce you with some experimental apparatus which I am using in this video. There are two blocks which I will use as mass. This is wooden block and this is a glass material. And the glass is heavier than the wood, and there is one ping pong ball, elastic band, a tip top pen in the head, and a fidget spinner. So let's start our video. The first law tells about the inertia. That is, if we do not apply the external force, the particle or the mass or the body in rest will be in rest, and the moving body will keep moving for unlimited times if we do not apply force. So this is one of the wooden block I am using. If I put it on the table, this will not going anywhere or will not go anywhere until I touch this like this. If I applying force, I am applying force, external force, so that's why the body is moving. But if I do not apply force, it will be here for infinite times. And the moving body, as I cannot see you some moving body here, but I am trying to explain it with this fidget spinner. So this is a moving fidget spinner. It will move around 1.5 minutes or 1 minute and 30 seconds. But if we use a very good bearing inside or use a lubricant or in a perfect condition where there is no air outside or the bearing is nearly frictionless, then it will move for unlimited times. Let's we assume that our 1 minute 30 second is unlimited time or infinite time. Then if I start moving this, it will not stop until 1.5 minute. But I have to apply, if I apply force from outside like this, it stops immediately. Depending on my force applying on this, it stops, takes time. If I apply force very gently like this, it stops gradually, taking time. But if I suddenly stop it, it will stop immediately like this. So if we don't apply external force, the spinner will keep moving or keep spinning for 1.5 minutes or 1 minute and 30 seconds. So this was our first law, that if we do not apply force from outside, the moving body will move continuously and the body in rest will be in rest for infinite time. For the experiment of second law, that is the acceleration of a body or a mass will depend linearly proportional with the force applied on the body and inversely proportional to the mass of the body. So now I will see you how this happens. If we are using a different mass and the same force, the acceleration will be different for two body, and if we use the same force and same mass, and we use the same mass but different force, then there will be different acceleration. So I will vary the two parameters here, first mass and then force. So I am using here this glass cube. The glass cube is a little heavier than this wooden cube, and for applying the force I am using this TikTok pen's back side. There is a spring inside, and the potential energy of the spring will be used as the force element or the force applier. Okay, and there is also a different force applier, or which will be the rubber band. Now let's start. What I am doing first is, hope you can see this yellow line here. I am marking this yellow line here with my marker. You cannot see for the background of the table, but I can see this. So this is the yellow line, and what I am doing, I am placing these two cubes side by side on the same line. Now I am using this pen's pusher to push this element. First the heavier glass element, this amount of move, and the little, and then the wooden element, this amount of move. And I will now measure the change. The glass element, the glass cube moves about the 4 centimeter, but the wooden cube moves about 8 centimeter, nearly double. So what I am trying to say is, as the wooden cube is have the less mass, but I am applying the same force. I was applying the same force with this pen, so the heavier object had a less acceleration due to this comparing with this lighter element. So the less acceleration produced a less velocity, and the less velocity helps this to overcome the less distance than this wooden cube. The wooden cube traveled the higher distance than this heavier glass cube. So the same amount of force but the different amount of mass creates a different amount of acceleration, which results in different amount of displacement of these two body. Now again I will do this experiment with some different force. Now this is our line, and I am putting this wooden element here and the same TikTok pen. This time our force will be different. How? I will show you later. The plane applied some force and it moved about 7 centimeter. Mark the number 7 centimeter. And now I am applying some force with this rubber band, and the rubber bands will also use the elastic force like this, and this will also create some force. Now I am using this force. If I applied little more force, the wooden block could have go out of my table, and it moved around 21 centimeter. So for the pen it moved 7 centimeter, or for the elastic band it moved around 21 centimeter, 3 times more. So the force applied by the elastic band was higher than the or could say the 3 times more than this pen or this spring, the pen inside the pen. So here we used the same block for a different force, and we observed this different acceleration, and those acceleration results some displacement of this element, and you can observe the element easily, displacement easily, and can conclude that if we change the force for the same mass, if we apply higher force, then the acceleration will be higher. But for the if we use the higher mass, the acceleration will be lower. So the acceleration is inversely proportional with the mass and linearly proportional with the force. Now the third experiment, or the third law, that is, each and every action has an equal but opposite reaction. The best example or best experiment you can perform in house is if you tap a surface with your hand like this, you can feel pain or something reaction force in your palm against that table. So if you tap with a higher velocity or with a higher force, the pain in your hand will be higher. So if I tap like this, there is a little pain in my hands or little itchiness in my palm. But if we tap like this, the pain will be higher. You can feel it. So the higher you apply force, that surface or the or where you applying the force will return back some reaction force on the applied particle or the applied mass, and you will feel it. So this is the reaction force when you are applying. Now there is an experiment I can perform. I am using this ping pong ball, which is made of rubber, and it drops quite well in a hard surface. So if I drop it on the table, you can show that it is dropping many times. Because due to the gravity, the ball is coming down, and due to that applied force on this mgh, that is the gravitational kinetic energy, this applied force, this is applying the force on the table, and the table is returning back the same force on this ball, and due to the elastic property of the high elastic property of the ball is bouncing on the table. But where I am sitting, this chair is little bit spongy, so it will absorb maximum amount of force applying by the ball. So hope the ball will not bounce like the table. Now let's have some experiment like this. You can see that, but if you see closely, so you can see that the ball is not bouncing like the table, because the chair or the foam on the chair is absorbing the maximum energy and not returning back the reaction force, and that's why it is not jumping or bouncing on the chair. But the table is not absorbing the force applied by the ball, and that's why it's returning back the every amount or every bit of force to this ball, and the ball is bouncing. Give some experiment if I give some example, that suppose you are jumping from one part to another in your room floor, you can jump easily, or in a high jump, if you like a frog jump, we are very used to with the frog jump in the school's days. because it was kind of exercise, a punishment, or was like some athletics. The frog jump, you can jump on the hard surface or in the ground or on the floor easily, but try to think that if you jump on a trampoline is something, there is a well like element, and there is a rubber sheet on that hole, and you can jump over it like bing 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 bing. That is a trampoline. So if you, or just simple imagine, if you tie a net on the four corners or of your house, and the net is floating like this in the air. I'm trying to make some like that. This is one of the duster I'm using, and okay, so you can see that this area is not very hard. So if one try to jump here, it is like some trampoline. You cannot jump easily or jump from one point to another on a trampoline, because the trampoline will not give you back that force, that reaction force which you are applying on that trampoline surface, and that's why you cannot get that amount of energy or that amount of reaction force to move your body from one point to another. But on a hard surface, the hard surface will give you back all the energy, all the force that you are applying with your legs on the surface, and that energy or reaction will help you to move from one point to another on a hard surface. So this is the equal and opposite reaction force, and the law is verified thus. Hope you have learned all the laws carefully, and hope you have understand all the experiment I have done. So if you like this experiment below, and if you want to see such experiments later, then type it down there. Thank you.